Welcome back students, it's Ranvija back to you with my second video tutorial for mathematics of class 10th. In my previous video I told you how to use my videos and I hope you'll follow the instructions that I gave you. If you follow them, I'm sure that after few days you'll start enjoying mathematics and it will become very interesting for you to solve problems in mathematics. In the beginning it may irritate you a little bit, but you don't need to be afraid. If you keep practicing, you'll definitely overcome the situation. So you are gonna be no more dumb in mathematics. Let's begin with the first lesson, that is real number. First of all, let's have a look what we already have gone through in class 9th. Let's understand the number system. So first of all, natural numbers. Natural numbers are the numbers used for counting, hence natural numbers are counting numbers. Few examples are there: 1, 2, 3, 4, 5, 6, 7, 8 and so on. These numbers are natural numbers. Natural numbers are very easy to understand. Whatever is there present in the nature, we can count it and we use some numbers to count it. These numbers are the natural numbers. 0 is not there. If we add 0 to these numbers, it becomes the set of whole numbers. The next is whole numbers. All the natural numbers including 0 are called whole numbers. Just like natural numbers, whole numbers do not include any fraction or decimal part. If you notice the difference between natural numbers and whole numbers, only 0 is an additional number in the set of whole numbers. Otherwise, all the natural numbers are present in whole numbers. And this is the reason why we call natural numbers the set of whole numbers. Hence, all the natural numbers are whole numbers, but all the whole numbers are not natural numbers, as whole numbers include 0 and 0 is not a natural number. Next, integers. An integer is a number that can be written without a fractional component. It can be positive or negative. Examples are -3, -2, -1, 0, 1, 2, 3, 4, 5, 6 and so on. We notice all the whole numbers are there in integers like 0, 1, 2, 3, 4, 5, 6 and so on. Some additional numbers are there that is negative of natural numbers like -3, -2, -1. It may be -4, -5, -6 and so on. These are additional numbers in integers. We can say all the whole numbers are integers, but all the integers are not whole numbers, as integers include negative of natural numbers. -1, -2, -3, -4, these numbers are called negative integers having a negative sign before them. 1, 2, 3, 4 etc. are called positive integers. 0 is neither positive nor negative. Next, rational number. A rational number is any number that can be expressed as the quotient or fraction p upon q of two integers p and q with the denominator q not equal to 0. Since q may be equal to 1, every integer is a rational number. A few examples are there: -7 by 2, -3, -8 by 3, -2, -1, 0, 4 by 11. These numbers are the examples of rational numbers. Simply we can say rational numbers are the ratio between two integers, and the two integers are p and q, where q should not be equal to 0, as q is the denominator and denominator should not be equal to 0 in rational numbers. All the integers are also rational numbers, as 1 is there in the denominator of integers, and similarly natural numbers and whole numbers are also rational numbers, as they are included in integers. Rational numbers may be terminating decimals or non-terminating repeating decimal. Examples are 1.3 is a terminating decimal, or 1.333 non-terminating repeating nature of decimal. An irrational number is a real number that cannot be expressed as the ratio of integers, such as p upon q, where p and q are integers and q not equal to 0. Examples are root 2, root 3, root 5, root 6, root 7, root 8, root 10, 2 raised to the power 3 upon 2. As these numbers cannot be shown as the ratio of two integers such as p upon q, where q is not equal to 0 and p and q are integers. If you find the square root of these numbers, you will find non-terminating and non-repeating nature of decimal expansion. Pi is also an irrational number because it has non-terminating and non-repeating nature of decimal expansion. Approximate value of pi up to few decimal places is as follows. A few more examples of irrational numbers: 2.30, 300, 3000, 30000. As the number is non-terminating and non-repeating nature of decimal expansion, the number is irrational number. Five upon 0 is also irrational number. As it is not defined, 5 cannot be divided by 0. In fact, any number divided by 0 is an irrational number. 3 raised to the power 3 upon 2, it is again irrational number, as if you solve 3 raised to the power 3 upon 2, you will find non-terminating and non-repeating nature of decimal expansion. Square root of 32, it is again irrational number. 3 plus square root of 2, it is again irrational number, as the sum of a rational number and an irrational number is always irrational. Imaginary number. Square root of any negative number is said to be imaginary number. Square root of -1, square root of -2, square root of -3, square root of -4, square root of -5, and so on. These numbers are called imaginary number. So the square root of these numbers cannot be computed. Square root of -1 is denoted with iota, and hence square root of -2, square root of -3, and square root of -4 can be expressed as square root of 2 into iota, square root of 3 into iota, and 2 iota respectively. Next, real numbers. The real numbers include all the rational numbers and all the irrational numbers. Any real number can be determined by a possibly infinite decimal representation such as 75.0000 or 3.45685246755526 and so on. With the graph given below, we can easily understand the real numbers. Real numbers are classified into two categories: rational numbers and irrational numbers. Now, a number that is expressed in terms of the square root of a negative number, usually the square root of -1 represented by iota or j. Real numbers. This is very simple graph to understand what are real numbers. Simply we can understand the real numbers with the graph, as real numbers are classified into two categories: rational numbers and irrational numbers. And rational number includes integers, whole numbers, natural numbers. And here integers include whole numbers and natural numbers, and whole number includes natural numbers. And when irrational number is added to rational numbers, they construct the set of real numbers. If you want to analyze the graph, you should pause the video and try to understand the numbers graphically. You have understood these numbers very well. Prime numbers, a number that is divisible only by itself and 1. For example, 2, 3, 5, 7, 11, 13, 17, 19, 23. These numbers cannot be divided by any number other than itself and 1. So these numbers are prime numbers. These numbers have only two factors, 1 and the number itself. So 2 can be divided by 1 and 2 only, 3 can be divided by 1 and 3 only, 5 can be divided by 1 and 5 only. And composite numbers, a whole number that can be divided evenly by a number other than 1 or itself. For example, 4, 6, 8, 9, 10, 12, 14, 15. These are the examples of composite numbers, as these numbers can be divided by numbers other than 1 and itself. In case of 4, it can be divided evenly by 2 as well as 1 and 4. In case of 9, it can be divided by 1, 2, 4 and 8. So these numbers have more than 2 factors, and hence these numbers are composite numbers. 1 is neither prime number nor composite number. Similarly, 0 is also neither prime nor composite number. Co-prime numbers. In number theory, two integers a and b are said to be relatively prime, mutually prime or co-prime if the only positive integer that divides both of them is 1. So the only common positive factor of two numbers is 1. Simply we can say, if the highest common factor or greatest common divisor of any two positive integer is 1, the numbers are said to be co-prime numbers. It's very easy to understand. Co-prime numbers have only one factor, that is 1. There is no factor other than 1 in the set of co-prime numbers. For example, 14 and 15 are co-prime, being commonly divisible by only 1, but 14 and 21 are not, because they are both divisible by 1 and 7. Similarly, 2 and 3, 3 and 4, 3 and 5, 4 and 5, 5 and 6, etc. are pairs of co-prime numbers. Odd numbers, it's very easy to understand. I hope you already know these numbers. The natural numbers which are not exactly divisible by 2 are called odd numbers, such as 1, 3, 5, 7, 9. These numbers are not divisible by 2. And on the other hand, even numbers, the natural numbers which are exactly divisible by 2 are said to be even numbers, such as 2, 4, 6. These numbers can be divided by 2. Hence they are even numbers. Multiples. Multiple of a number is obtained multiplying it by a natural number. For example, multiples of 2 are 2, 4, 6, 10, 12. As you see here, these numbers have been obtained by multiplying 2 by some natural numbers, as 2 has been obtained multiplying 2 by 1, 4 has been obtained multiplying 2 by 2, 6 has been obtained multiplying 2 by 3, 10 has been obtained multiplying 2 by 5, and hence these numbers are the multiple of 2. Multiples of 3, again 3, 6, 9, 12. I hope you understand these numbers well. Multiples of 4, 5, 6. So I expect that multiples are very much clear to you. All the multiples of a number are exactly divisible by the number. For example, 2 exactly divides all its multiple, 2, 4, 6, etc. So multiples of a number are exactly divisible by the number. Common multiples. As the name suggests, common multiples are the multiples common in 2 or more numbers. Now common multiples of 2 and 3 are, you can notice, 6 is common in the multiples of 2 and 3, then 12 is common, then 18, you will find 24 too. So you will find these common multiples between the multiples of 2 and 3. Common multiples of 2 and 4 are 4, 8, 12, 16. Common multiples of 4 and 6 are 12, 24, 36, 48, etc. 6 is the common multiple between 2 and 3 and the lowest one. Hence 6 is what? The lowest common multiple of 2 and 3. Again 4 is the lowest common multiple of 2 and 4, and 12 is the lowest common multiple of 4 and 6. Lowest common multiple of 2 and 3 is 6. Lowest common multiple of 2 and 4 is 4. Lowest common multiple of 4 and 6 is 12. Now, factors, a number or quantity that when multiplied with another produces a given number or expression. As I told you, factors of a number can divide the number completely. So here 1 divides 2 completely and 2 divides 2 completely. 1 divides 3 completely and 3 divides 3 completely. No other factor than 1 and 3 is there. Now 4 can be divided by 1, 2 and 4. 5 can be divided by 1 and 5. 6 can be divided by 1, 2, 3, 4. 1, 2, 3 and 6. So 1, 2 are the factors of 2. 1, 3 are the factors of 3. 1, 2, 4 are the factors of 4. As these set of numbers can divide the corresponding numbers completely, hence they are the factors of the corresponding numbers. So the conclusion is factors of a number completely divides the number. In other words, a number is completely divisible by its all the factors. As 2 is divisible by its all the factors, that is 1 and 2. 3 is divisible by its all the factors such as 1 and 3. 4 is divisible by its all the factors such as 1, 2 and 4 and so on. Note, numbers having only 2 factors are prime numbers. Here you should notice 2 has only 2 factors 1 and 2, 3 has only 2 factors 1 and 3, 5 has only 2 factors 1 and 5. So 2, 3 and 5 are prime numbers. I already have explained prime numbers, so I don't need to explain more. Common factors are the factors common in the factors of 2 or more numbers. Like common factors of 2 and 3 is 1. You should notice the common factors between the factors of 2 and 3 is 1 only. No other common factor is there. There are 2 common factors between the factors of 2 and 4, that is 1 and 2. Common factors of 4 and 6 are again 1 and 2. As I told you, common factor of 2 and 3 is only 1. As in common factors of 2 and 4, there are 2 numbers 1 and 2, and the highest of them is 2. So highest common factor of 2 and 4 is 2. Common factors of 4 and 6 are 1 and 2, and the highest of them is 2. So 2 is what? 2 is the highest common factor of 4 and 6. So it's very easy to understand. From the above examples, it is clear that highest common factor of 2 and 3 is 1, highest common factor of 2 and 4 is 2, highest common factor of 4 and 6 is 2. So in this video I explained number system, which is very important to continue with the real numbers in class 10th. In next video I will continue with the chapter real number of class 10th. I hope you liked my video. If you really liked my video, please share and like. You may also subscribe to get the updates about new videos. Thank you. Thanks for watching.